Hey everyone, so today we're going to go over reverse linked list. If you haven't seen my previous video on how to create a linked list, I'd suggest checking that out first. But let's go ahead and jump right into this one. So to reverse a linked list, we're going to take in the head of the linked list and reverse the entire order. So we have, A, B, C, D. And what we're looking for is basically for A to be the tail now and D to be the head. So we know when we're looking at a linked list, we're starting at the beginning node here, and obviously there's a traversal path that goes to B, then goes to C, then goes to D, and then really nothing afterwards. And so since we want to do this in place, we want to make sure that we kind of, as we go, we're changing things around instead of like going all the way to the end, for example, and then trying to work your way back. That's going to get really complicated and hard. So let's just start from the beginning and move forward. So the first thing we want to keep in mind is keeping track of where we are in this progression. So I'm going to say track where we currently are. That's one thing we need to keep track of as we move forward. So we know in this situation, the next is not going to be node B anymore. It's actually going to be null. The same way that the tail end of this linked list with D, the next is null here. Since it's in reverse, A actually needs to point to null instead of pointing to node B. So we'll take that out. But now the problem is we can't actually traverse the linked list, right? Because we've lost the value of next. It's just pointing to null. So we can't say, okay, now that next is null, go to next because next is null. We can't go past that. So what we need to do is track the value of current.next. So to get around that, we can create a temporary variable to keep track of what was originally next in front of it, which was node B in this situation. So we can say temp variable to keep track of what's in front of the node. So let's pretend we have both of those and we use that temporary variable to jump over now to node B. Now inside of node B, we know that instead of pointing to C, it needs to point to A. So not only do we need to know what's in front of B, but we need to know what's behind B as well now. So this needs to be set to the previous node, which is node A, right? So on top of keeping track of what's in front of it, we'll also need to keep track of what's behind it. Okay, so now we are done with node B. We jump over to node C. And the way we do that is, of course, keeping track of what's in front of it. And now we update node C with what was behind, which is this variable number 3, what was behind node C, which is now node B. And we do this all the way to the end. And of course, since D is now the head, the next for this one is going to be pointing to node C. And now that pretty much everything is pointing backwards, we are almost done. So again, remember, I'm going to jump back to these as we kind of create it when I code it out. But there's 3 things we're keeping track of: where we currently are, what's in front of the node, and what's behind the node. So let's jump over to the code to kind of go through how to actually code this out. Okay, so in my previous video, which was on linked lists, went over how to create a node, how to create linked lists and stuff like that. So you can see, for example, here, I created a list, which is a new linked list, and I appended A, B, and C, and it outputs a linked list that has a head of node that has data A, and it keeps on pointing to the following nodes in front of it. Okay, so we'll create a method just called reverse list, and we actually don't need to pass anything in because we have access to the head of the linked list just by typing in this.head. So if we do console.log and then do this.head and then call this, you'll see we have access to the head. So no need to do anything. We don't need to pass anything in as a parameter. So we'll just say let current equal this.head. And similar to before, we could traverse it by just doing a while loop. So while current is not equal to null, current is equal to current.next. And if I console log current, you can see that the first time I run it, we're at the top node A. The second time we're at node B, and the third time we're at node C, and then it stops because, of course, when it goes to current.next at that point, current would be equal to null because current.next is null, so it no longer repeats at that point. Okay, so that's cool, but we can't set current equal to current.next. That's not going to work because current.next in this situation when we're here is going to be pointing to B, right? But we need to actually point to null. We can't go in front of it, it has to go behind it. So instead what we're going to do is we're going to specify current.next is equal to, And while we could put null, we're actually going to utilize a variable to keep track of our place as we kind of progress through this. So instead, what we're going to do is say let previous equal null as we initiate it, and we're actually going to set current.next equal to previous. So now current.next is equal to null. In this situation here, current.next, which would be this node here, is going to be equal to null. But now the problem is we can't actually go to B anymore, right? Because the value of next is gone. So we're keeping track of where we currently are by using current. We know that current is this head, and then we're on the top of the node that has a value of A, and we have everything in front of us. But we need to create a temporary variable to keep track of what's in front of this node now, because if we reassign current.next, which is this one, if we reassign this to null, then we'd lose track of what's in front of it. So what we can do is we'll create a temporary variable, and we'll just say next node is equal to, and we'll do current.next. So before we lose track of what current.next is, we're going to save it in next node. So that means that, for example, in this situation, next node would be equal to node B, and then current.next, which is where we are right now, is equal to null. The reason we're doing that is because we need to progress over from node A to node B and not lose track of what was on, the current.next. And what we can do is, instead of doing current is equal to current.next, we'll just do current is equal to next node. We can't do current.next anymore because current.next is null right now. So if we set current equal to null, then this while loop will no longer work because current is null. So now next node, which is node B, is the current node. Okay, so we jump back to the top now. So we are, while current is not equal to null, so we're at node B, then basically let next node equal current.next. So that's pointing to node C. But the problem is, when we do current.next is equal to previous, previous is equal to null. So we don't want this to be, because we're at node B right now, right? So we don't want this to be equal to null, because then we lose this point back. We need to point to node A. So what we can do is, at this point, after we set current.next equal to previous, we're going to take previous and actually update it to the current node. So let me reset everything here and kind of go through in detail what's happening here as we run through our code. So the first time around, we are looking at current is equal to this head, which is basically means it's pointing at A, and previous is equal to null. So let's write those out. So basically previous is equal to null, and we know that currently we're on this head, which is node A. So the first time we go through this while loop, current is not equal to null, current is equal to node A. So we're saying let next node equal current.next. So we're going to create another variable here that's just called next node, and it's equal to current.next. Current.next is node B, right? And you can see right here, it's pointing to node B. So basically, next node is basically node B. Then we're saying current.next is equal to previous. So that means in this situation, this next is not going to be equal to node B anymore. It's going to be equal to previous. Right now, previous is null. So we're going to say, okay, you are no longer pointing to null to node B. You're pointing to null, or sorry, to previous, which is null. Great. Now we're setting previous equal to current. What's the current node? We're on node A, right? So now, if I move these over, so now previous is going to be equal to node A. Okay, cool. And then after that, current is equal to next node. Well, next node is node B. So now current, where we are right now, is going to be here. We're currently on node B. Now we transition over to here. We still have previous as node A, and we have next node as node B. Current is not equal to null. It's equal to node B. So let next node equal to current.next. What's current.next for node B? Current.next is node C. So we're going to update next node to be node C. Current.next is equal to previous. What's previous? Node A. So we're going to say, okay, now you're, instead of being equal to null, you're going to be equal to node A. Previous is equal to current. What's previous right now? Previous is equal to node A, but we're setting it equal to current. What's current right now? We're currently on node B. Finally, current is equal to next node. So now we jump over to C. and it keeps on continuing. Finally, we're going to get to node D, right? And as you saw before, when we had a normal linked list A, B, C, D, D was pointing to null because nothing was in front of it, right? So if I bring that over here, what's going to happen, as you know, is that we're going to keep track of the current.next value by putting it as the next node. So that will be now, instead of the next node in front of it, it's going to be null because it's keeping track of the next, which there is no next for D. And then the previous, which was node C, is going to be the current.next. So basically it'll be pointing to node C. And what's going to happen is that after we're done with all this, we're going to set current equal to next node. If current is equal to null, we no longer qualify to run this if statement because current is equal to null. And then after that, all we have to do is just return previous. So if I run, if I console log this, so console log list.reverse, and let me pull this up, you can see that we're starting at node C as the head now. That points to node B, and then that points to node A, and then that next is now equal to null. So now A is the tail of that linked list. I know this was a lot, so hopefully the example with this text here makes a little bit of sense. I really try to walk through every single iteration of it to make more sense for you. But if you have any questions, please drop them down in the comments below. I hope this video was helpful for you. If it was, please give a thumbs up and subscribe. It really helps my channel to grow. And I'll see you on my next video.